Hello, ladies and gentlemen. My name is Rudolf Duester. I am CEO and Managing Director of SEBA Hydrometrie, a company close to Munich in the southern part of Germany. The headline of my presentation today is "What you see is what you measure," and later on you will understand what that means. First, I'd like to introduce the company as such, so that you have a common understanding of what we are doing. SEBA Hydrometrie has been founded about 55 years ago, and we are one of the world-leading manufacturers for hydrological equipment. And hydrological equipment, hydrological regime for us as well, means the entire cycle of water, including surface water, groundwater, wastewater as well, and of course water quality when it comes to issues in connection with measurements in the field. We supply the entire chain of mobile and stationary equipment for hydrological regime, including different data loggers for the individual task, which all goes back to the same core. So software for configuration, etc., and operating the systems is common software for all of them. We work with World Bank, United Nations, UNDP, KfW, FAO, etc. The presentation today will be for a new system, a new innovation of our company, where we use camera to execute the measurement of rivers, and we do one measurement in one step, which means a surface detection of surface velocity as well as water level. And by observation of camera, we detect the structure on the surface. So what is the key feature of it? It's a camera-based system, and it's a direct calculation of discharge at site. So we don't send this video streams to elaborate them then in a central hub. We calculate everything in the field, so the intelligence is already in the field, so that even if the infrastructure is going down due to disaster situation, the system is going to continue. We have the camera installed at the river, observing the entire surface, and therefore it remains unaffected by floods and vegetation. You see different reference points, here, which are needed to bring camera in position to have correct measurements in the cross section, and by calculating water level, velocity, and the cross section, we come to the discharge of the river. To do so, we have to execute calibration measurements with different methods. In that case, we display ATCP measurement as a reference that can be done within the cycle. So if we look inside the system, you see the different electronic components installed in the field, and you also can detect the camera here in the upper corner. It's a very quite compact system, which not necessarily needs power supply. It needs just a solar panel and a battery it's operating on 12 volt. We have a lot of applications in between, around 200 units. You can have the same system also to be used to observe the surrounding conditions. So normally it is in operation mode to measure the velocity, but when you enter with your mobile phone into the system on the surface, you can also look around and see how is the situation. Is there landslides? Is there heavy clouds, heavy rain? So all this can be observed with the same system if you just access to it. So it's measuring during day and night by detecting or emitting infrared light to the measuring cross-section. Now you will see how the system, while the camera is moving around, You can zoom in, you can zoom out, and by that way you have a multiple function of the system as such. In that case, it was a observation site for a train track, where for security reasons they wanted to observe the system to decide whether the train should be stopped and the traffic should be stand for a while. So here we have an application in Australia, where we're measuring somewhere in the outback the conditions of a river, which is normally totally dry and only during rainy seasons gets some water. So the system has a trigger sensor also to become active after water is detected. That reduces the number of calculations, reduces the energy consumption, and also reduces the data to be processed. Another example is somewhere in the southern part of Germany, where we detect the water velocity of a small flood, and that is the result of a measurement which you achieve at site. Another location, another river, another evaluation. As you can see here is the detection of the water level, which gives you a clear line between air and water. Maybe wrong button. Good. Here we are under alpine conditions where you have a lot of energy in the water. As you can see, it's a solar panel operated system. Here is a system which was destroyed completely. The radar sensor, which was implemented before, has been gone due to a avalanche, and now it is detected by a camera where we measure the entire cycle. As you can see here, there is the measurement section, which is now under active mode. We can also go to wide rivers. This section, for instance, is 200 meters wide, where the camera is installed somewhere in the middle of the bridge, and it is detecting in 3 sections by moving from one section to the other, and detecting the water level in one process, and then combining all the different individual evaluations into one image afterwards. That is the result, what you see with the 3 sections. And here is the detection of the water level. Another location at Rhine River, where we are about 250 meters wide, and so just another application. This is at the Danube River. You see how it looks like. Here we have the station zooming in, and the camera is placed here on the wall at that base. This is a bit special. It's in the Emirates, where we measure in wadis, which normally are 360 days dry, and only 5 days when they have heavy rainfall, they get a flood, which then is immediately detected. This is one of our biggest applications, where we measure in Vietnam at the Mekong River, which is at this location about 600 meters wide. Again, the same evaluation and the composite of the different measurements. Bless you. And now we have access here to the portal, to the web portal, where we do the evaluations or the handling of the data and the management of the data, where you can check them afterwards, the quality of your results. wrong button. It's me. My thumb is doing what he wants. Yeah, so it's again the result and portal. Then if we go to some events, for instance, this was in Spain where the normal flow was below 50 cubic meter per second. And at a big event that time went up to nearly 1,000 cubic meter per second, which was entirely measured. It was a 500 years event, which was detected shortly after the installation. So we were very lucky that we had the system in and got that special event. So here you can see the development of the water level rising in the first event, which was still going only to that level. If you see this one, this was about 1,000 cubic meters per second, where afterwards the entire structure here of concrete was destroyed. And we still have the entire cycle of that event, which was of course very valuable for the hydrologists to elaborate the same, because they didn't have to have the chance before. Here's a second case study, which we did in the UAE. There you have the situation that the system is measuring and detecting a flood within a 15-minute cycle. And you see it was really a flash flood coming very, very fast and then releases slowly. But of course, so the entire thing was then going within just a couple of hours. So if you don't detach that with the camera, the information is more or less gone without getting further insight. So the conclusions: camera-based systems gives you much more insight into the regime, also understanding the situation when a measurement is taken. And beside the measurement, we also transmit video sequences which we are using, or at least images. So you have a total safety on the capturing your measurements. This is the example of using the same algorithm as an app. So that means it's a mobile system. You can go to the site, which is pre-calibrated by the markers, and the system has the cross-section in the database, and every time you go there, it needs a 4-second video, which is recorded very fast. So after the recording, the evaluation process is getting started. So since you are not able to come exactly to the same position, therefore we record the reference points one more time, and geometry is known to the system. So then we start to detect the water level, and after that the video is processed in your smartphone. So you can even operate that offline. It is not necessary to have an online connection to a data hub. Very fast results, which in some hydrological services is taken now as a reference measurement every time they go to the site, just only to capture the information of that moment. So then the data goes back when your smartphone is online again. Then the data will be transmitted to the database where they are kept, and where you can use this information then for further evaluation at a later stage. So the location we have chosen here was in Zurich, and is going through the different steps of processing. So all this information are in the database, and you have a free access to that. This is also available as a free of charge trial for a certain period of time. The only thing, of course, is the calibration of the site or the preparation for measurement. We also use drones for doing the same measurement as such. So the most important thing is that the calibration or the understanding the geometry of the site is the most important point. It's even more important with the mobile system compared to the stationary system, since you are moving, not finding exactly the same spot. So for you coming to good results with the mobile app, it really needs some training and preparation. But once a station is prepared, you can use this information more or less. It is. Thank you very much. If there are any questions coming up, I'm still here for about half an hour. After that, I try to get my plane. Thank you.